Okay, hi, good day everyone. This is the famous quadratic word problem. That's what I call it. That's what I think it is, okay? As we get into quadratic functions, what you're going to notice is that you're going to get a word problem. And that word problem is going to deal directly with those vocabulary words that you have there, okay? Some of those words you already know. You know what an axis of symmetry is from geometry. You know what a maximum is. You know what a minimum is. You know what the x-intercept is as well as the y-intercept. These are all words that you are familiar with, okay? We've talked about the standard form for a quadratic function, and we have not talked about intercept form yet, but you are familiar with it because you've multiplied using a box method or FOIL. So that's all the things that you are familiar with. Now, if everything that I just listed here is not something that you feel like you are familiar with, go ahead and type something in the chat box or ask one of your teachers to by email if you like, okay, so that we can help you. Keep in mind, when I get excited, I talk fast. So if you don't understand something that I said, feel free to go back and rewind it or just ask me. Okay, so here we go. This is how the problem goes. Pick a name. Your name, my name, whoever name. This person is going to kick, throw, toss a volleyball, basketball, football, whatever. What is the name? These are the types of questions that you get. Okay, they can be written in different ways, but they pretty much directly tied to those vocabulary words. So one of the first questions you'll get is, what is the name of the function that mimics the path of the soccer ball? Now, what you see there in that kind of greenish color here, I don't know. But yeah, what is that path? What is the name of that function? Then you'll be asked to describe the path of the function. In a few, you're going to be asked, does the graph have a maximum value or a minimum value? How long did it take the ball to reach its maximum height? How high did the ball go in the air? At what point did the ball reach its maximum height? How long was the ball in the air? So all of those things are tied directly to the vocabulary words that you have here on this slide. So the next thing that I'm going to show you is kind of how you can identify those things if you would just draw kind of a path to it. So if you have not already, I want you to grab paper and pencil and you can sketch it, okay? This is for your note purposes, okay? If you want to sketch it on a class kick and then come back and look at it, that's fine with me, okay? It's whatever works for you. But I want you to kind of see if you can put a point by where you think the maximum or the minimum value is. Write it down if you think you know the name of the function. What is this path? What do we call that path? That path that makes this U-shaped graph. Okay, if you did the first class kick, you know what that is. Path, and the word starts with the same letter P. How long, what do you think would represent how long it took for the ball to reach its maximum height? All of those types of things, okay? So pause me for a second, write that down, scribble it down wherever you choose, and then come back, okay? All right, people, so here we go. What you see now is a depiction with the vocabulary words for what you saw on the last slide, okay? So some things to point out. You have, they'll say, oh, Johnny kicked the ball from his foot was 3 feet off the ground. The ball landed here, or this graph, this equation represents what he did. So they'll ask you for certain things, but they won't say what's the y-intercept. They'll ask you at what height did he kick the ball. So you'll have to determine what is the y-intercept. Okay, notice that this line here in yellow represents your y-axis, which represents the height, and I have the height written there. And then you have your x-axis, which runs left to right, horizontal. And that x-axis represents time in the case of this problem. And then, just in case if you needed a reminder, oh, I didn't put my parentheses around the origin. Excuse me. All right. Boom. We got to make sure our points look right. Boom. Okay, so that's the only point that I'm giving, because to go into something more detailed would be too much. Okay, so they may ask you, at what height did he kick the ball? Or that would be your y-intercept. Okay, once you reach this point here, and I know that it's listed for you, but at what height, what was the highest that the ball went in the air? That will represent your maximum, because that will be the height here. So notice I have the maximum written in the position of y in terms of our coordinate, because our maximum value is going to be our y value at this point. So then you have your axis of symmetry. Your axis of symmetry will typically cut the parabola in half. Okay, it is the line of reflection for a parabola. Okay, your axis of symmetry is this vertical line, and even though it's a vertical line, it is normally written with x equal some number. Now, that might be something that you knew already, and if so, great. But when you write the axis of symmetry, it should represent a line of symmetry, and that line will always have an x. And something that I told my students in the past, and it may help you out. Here we go. Axis of symmetry is spelled A-X-I-S. Well, if you remember that is x is, because is in a math class means equal. We would say 3 plus 2 is 5. 2 plus 2 is 4. 2 times 4 is 8. So is in a math class is an equal sign. So long as you remember that the axis of symmetry is written as x equal, and the maximum value is going to be whatever y equals. You are halfway there to getting at least 2 problems right on a quadratic type exam. Okay, you may not have one that just says quadratic exam, but that's something to keep inside your memory bank. Okay, then let's talk about the x-intercept here. Okay, the x-intercept will represent how long, at what time did the ball hit the ground. Okay, so we would say that ball, he kicked it from this height. So the ball went in the air from here, and then it landed here. So the total amount of time that the ball was in the air is the positive x-axis. I want you to see, and I can't draw it, shucks. Hold on. But if I was to follow the trajectory of the soccer ball, when it is at the other x-intercept, because this parabola would touch the x-axis technically in 2 places, we won't consider this x-intercept here. Notice that this x-intercept is to the left of the origin. It is negative. We can't go back in time. Time can't be negative. So when we look at what happened when you kick the ball, your start time is at 0. How long did it take for the ball to hit the ground? That's the x-intercept. Okay, what was the maximum height? That's your y value at the axis of symmetry. Okay, so what I'm hoping is that you'll be able to use this information to help you complete the vocabulary on the class kit. And if not, some of these vocabulary words are going to come up later, and we're going to graph them so that you'll be able to see what each represent. Okay, the only opposite, or the only other caveat to this type of problem is sometimes it'll be flipped upside down. Okay, and you'll have someone dove down into the ocean, and you want to know how far down they went, and different things like that, and how much time were they under the water. But all of those things can be found as long as you can identify what those vocabulary words are. And a lot of times in a math class, you need to make a drawing. Okay, so I hope this was helpful for you. If you need help, please say something. Okay, and let's have a great day.